Entropy, information, and the emergence of classical worlds, a conceptual synthesis across physical and biological scales. Abstract. This essay explores conceptual parallels between gravitational motion, quantum decoherence, biological evolution, and cognitive intelligence through the shared lenses of entropy and information. The goal is not to derive one domain from another or to propose a unified physical mechanism, but to illuminate recurring structural patterns. General relativity describes objects following geodesics, natural trajectories shaped by space-time curvature. Quantum decoherence describes the stabilization of classical outcomes through environmental interaction. Living organisms maintain order by accelerating entropy flow, and intelligent systems perform high-rate, irreversible computations. Although these processes arise from different mechanisms, they all contribute to the universe's irreversible accumulation of information. This is offered as a unified perspective, not a unified theory. 1. Introduction. Physics, biology, and cognitive science each describe distinct layers of the natural world, yet all unfold within the same thermodynamic universe, under the same arrow of time, and through processes that continuously transform quantum possibility into classical actuality. This essay follows a thread that runs through those layers, the steady production of irreversible information. The parallels we highlight are structural rather than mechanistic. Gravity does not compute, life does not seek entropy, and intelligence does not serve a thermodynamic purpose. But across scales, systems tend toward paths of stability, efficiency, and irreversible record-making. Recognizing these thematic similarities can help us see these domains not as isolated puzzles, but as connected expressions of the same underlying temporal asymmetry. 2. Geodesics and minimal disturbance. In general relativity, a freely falling object follows a geodesic, the natural inertial path defined by space-time geometry. Geodesics do not arise because they minimize informational overhead. They arise because of geometry alone. Yet there is an interesting alignment. Geodesic motion tends to produce minimal disturbance to the surrounding environment. A stone in free fall produces fewer environmental traces, fewer collisions, less turbulence, than an object being accelerated by an external force. This has nothing to do with the cause of geodesics, but it helps explain why geodesic motion appears so reliably stable in our classical experience. When decoherence does occur, geodesic-like trajectories are the ones that create the cleanest, least ambiguous environmental records. 3. Decoherence and the irreversible writing of classical reality. Quantum systems can exist in superposition until interactions with their environment destroy the delicate coherence among alternatives. This process of decoherence stabilizes one outcome from many possibilities, leaves persistent entropic traces in the environment, contributes to the arrow of time, transforms probabilities into recorded facts. The physics of decoherence is well established, though interpretations of its metaphysical significance differ. What is clear is that every decoherence event adds information to the universe's entropic record. One can picture this, metaphorically, as an expanding, fractal-like boundary where the universe continuously commits to specific outcomes. 4. Life as a dissipative structure. Living systems operate far from equilibrium. They maintain internal order by increasing entropy in their surroundings, a textbook example of Prigoghine's dissipative structures. Some researchers have proposed that certain non-equilibrium systems evolve toward states that maximize entropy production, MEPP. MEPP is appealing but not universally accepted, and certainly not established as a first principle of evolution. What is clear? Life channels energy gradients into work and waste heat, maintains low entropy locally while raising entropy globally, and leaves durable informational traces, genomes, ecosystems, geochemical signatures. Life is not an entropy maximizer by design, but it is an unusually effective entropy processor by necessity. 5. Intelligence as thermodynamic computation. Information processing has unavoidable thermodynamic costs. By Landauer's principle, every irreversible computational step produces entropy. Brains and AI systems perform enormous numbers of such operations. Intelligent organisms do not necessarily produce entropy wastefully. They may be more efficient per computation than simpler systems, but because they compute vastly more, their total entropic footprint is larger. A concrete example illustrates this. Consider a foraging bird evaluating multiple food sources. Each decision, sensing, comparing, predicting, involves irreversible computations. Each computation generates heat. Over a lifetime, millions of such decisions make the bird a significant local entropy source. Intelligence amplifies entropy production not through sloppiness, but through sophisticated information processing. Intelligence is one of evolution's most potent methods of reorganizing energy flow. 6. Structural parallels across scales. These parallels are interpretive, not causal. Gravity, geodesics minimize environmental disturbance. Quantum, decoherence stabilizes outcomes by amplifying environmental consistency. Life, organisms maintain order by accelerating entropy flow. Intelligence, cognition produces high-rate irreversible information processing. 7. Scope and limitations. This framework is not a new theory of quantum gravity, a derivation of evolution from entropy principles, a claim that gravity optimizes information flow, a teleological account of intelligence, or an attempt to reduce biology and psychology to physics. This framework is an interpretive lens, highlighting thematic continuity between physical and biological processes without asserting shared causal mechanisms. Alternative views abound. Physicists disagree about deep connections between thermodynamics and gravitation. Biologists resist entropy-based teleology. Consciousness remains unsolved. This essay is a synthesis, not a solution. 8. Conclusion. Across scales, systems commit to particular histories. A falling stone writes a simple record. A biochemical cycle writes a biochemical record. A thinking organism writes a cognitive record. These irreversible commitments, mediated by geometry, decoherence, metabolism, and computation, collectively generate the flow of time and the structure of the world we inhabit. Seen this way, classical reality, biological life, and intelligence are not isolated mysteries. They are successive expressions of the same temporal asymmetry, the universe's ever-growing ledger of irreversible information.